This example is asking us to come up with a polar equation and graph it given these vertices. So one of the vertices is at -4, 3 pi over 2. So if I come down to 3 pi over 2, but I go -4, that means I'm actually going up 4 away from this. And that's one of my vertices. The other one is at 1, pi over 2. That one's a little bit easier to graph. So if those are the vertices, then this is not a parabola because a parabola only has one vertex. And it's not an ellipse because the ellipse would have to connect the two vertices, and that's not where the focus is. So this problem has to be a hyperbola based on where the two vertices are. If it's a hyperbola, that means I'm going to have a vertex right above that, or wait, that is the vertex. So I'm going to have a focus at the pole. I'm going to have another focus away that direction. And my hyperbola is going to look something like that. So that's what I'm trying to work with. So given these two vertices, knowing that it's a hyperbola, so E is going to be greater than 1, I can also determine that my directrix is going to have to be somewhere above the vertex. Because the way that a directrix and a focus and a vertex work for a hyperbola and for an ellipse and for a parabola is that if you look at them in a straight line, it's directrix, then vertex, then focus. Or the other direction, focus, then vertex, then directrix. So all that to say, my directrix is going to be above the pole. And because it's above the pole, my equation is going to be R equals EP over 1 plus E sine theta. Now I don't know the eccentricity yet because they didn't specify. And I don't know P yet because they didn't tell me where the directrix is. But what happens if we plug in one of the vertices? For example, 1 pi over 2, because that vertex is the one that is closest to the focus we're working with. So 1, which is R, is going to equal EP over 1 plus E times sine pi over 2. Sine of pi over 2 is 1. So 1 equals EP over 1 plus E. And we still don't know EP or E, so we're going to have to do something else. But these are the values that we have so far. Now I could come up with another equation, -4 plugging in 3 pi over 2. Maybe I have to use a system of equations to get it. Okay, I was pausing there because I was thinking about different methods. But so one of them is to plug in both vertices. We just plugged in one vertex, and we have 1 equals EP over 1 plus E. Well, what if we plug in the other vertex and see what we get? And color this one green so we can see the equation that goes with it. So this one's going to be 1 equals e times p over 1 plus e sine 3 pi over 2. Right, and actually it's not 1 equals, it's negative 4 equals. So going back to this equation, negative 4 equals EP over 1 plus e sine 3 pi over 2. And so negative 4 equals EP over 1 minus e. And that might look weird, but one thing that I notice is both of these have an EP. So I could say 1 times 1 plus e equals EP, or 1 plus e equals EP. For the green equation, I could say negative 4 times 1 minus e equals EP, or negative 4 plus 4e equals EP. And if they're both equal to EP, then I can set them equal to each other. So 1 plus e equals negative 4 plus 4e. I'm going to wind up with a 3e equals 5, and so 5/3 is e. So now I know there's a 5/3 for my e. And I have these equations relating e and p together. So I can take one of them, like this one, 1 plus e equals EP. So 1 plus 5/3 equals 5/3 p. So 8/3 equals 5/3 p. Multiply by 3/5, and 8/5 is equal to p. So my directrix is going to be 8/5 above the pole. 8/5 is 1.6. So this directrix equation is y equals 1.6. And if I plug my stuff back into my r equals equation, I have r equals EP, so 5/3 times 8/5 over 1 plus e, 5/3 sine theta. So on top, this is really just 8/3. And then we'll multiply the top and bottom by 3. So r equals 8 over 3 plus 5 sine theta. It might actually be faster to use what I know about directrices in the rectangular form. I know that the directrices in the rectangular form are equal to a squared over c away from the center. Well, based on where the vertices are, I could find the center. I have a vertex at 1 and a vertex at 4, essentially. So the center would be at 2.5. If I know the center is 2.5, or I know the two a values are 3 altogether, right? 4 minus 1 is 3. So a squared over c, like I could go through and do all those parts. I can have c is defined as the distance from the center to the pole, so that would be at 2.5. A is half the distance between the vertices. So 2a is 3, a is 1.5. So I could do a squared over c away from the pole. But it might be better just to lean into the polar form and give yourself a small system to work with.